Hey everyone, and welcome to this explainer. Today we're diving straight into the real engine room of modern edge computing, lightweight container middleware for edge cloud architectures. If you really want to figure out how the edge operates, and more importantly, how it scales without just leaning on traditional heavy cloud resources, well, you are exactly in the right place. This is your starting point.
So let's just jump right into the big question here. What does it actually take to master edge cloud architectures? Because let's be real, it's not just about throwing your code further away from the data center and hoping for the best. To actually master the edge, you've got to understand those highly efficient, super lightweight engines that are running quietly behind the scenes. Okay, here's our quick roadmap for this explainer. We're going to start with the edge computing journey, then move right into container tools and middleware. After that, we'll tackle storage and distributed systems, navigate some current market trends, and finally, wrap it all up by mastering our core learning outcomes.
All right, let's kick things off with Section 1, the edge computing journey, and really define our primary mission here. So everything begins with getting familiar with lightweight container middleware. We're talking specifically about taking tools you probably already know, like Docker and Kubernetes, and tailoring them for edge environments. Really grasping how these traditionally heavy-duty cloud tools get adapted for resource-constrained edge devices, that's absolutely crucial. It's literally the starting line for everything else we're going to talk about today. Because without nailing down these core middleware components, building a truly scalable edge architecture, it's just not going to happen.
Moving right along to Section 2, container tools and middleware, which is essentially the engine of the edge.
Now, when we actually bring Docker and Kubernetes out to the edge, we've got to strip away the excess. The focus here is 100% practical. It's all about adapting these containers for environments where, let's face it, memory and processing power are heavily constrained. We'll be looking at how you leverage open source tools to deploy your microservices right there, exactly where the data is being generated. This is what ensures your applications stay agile, totally resilient, and just incredibly fast. Okay, on to Section 3, storage and distributed systems. This is where we tackle IoT complexity. So, before your data can just flow effortlessly across a network, you really have to nail down the right edge storage architecture. Those traditional, bulky relational databases, they usually just fall flat out here. Instead, you're going to want lightweight, highly efficient mechanisms. Specifically, we're talking about key value stores. These are an absolute must-have for the kind of rapid, low-latency data retrieval you need at the edge. They let you do immediate localized processing, which means you need to completely bypass that agonizingly slow round trip back to a centralized crowd. And, managing distributed systems in IoT, that requires some seriously precise coordination. Just imagine a whole network of autonomous sensors humming along on a factory floor. If you want to prevent utter chaos, you need a perfectly synchronized sequence of events. First up is time ordering, making sure data gets processed in the exact, literal sequence it happened. Step 2 is clock synchronization, which is all about getting those totally disparate devices perfectly aligned on the same schedule. And then Step 3, the distributed snapshot. This one's super cool because it lets you capture a totally accurate, system-wide state of your entire network at any given millisecond. That brings us to Section 4, navigating current market trends, which is essentially your independent quest. Look, the edge cloud landscape evolves incredibly fast. Foundational knowledge is great, but it's just not enough on its own anymore. You've got to take the initiative to identify and analyze current trends in container technologies out in the market. I mean, the space is shifting daily. We're seeing new lightweight orchestration tools popping up constantly. Staying ahead of these trends? That's the secret sauce. That is what ultimately keeps your edge architectures relevant, scalable, and highly performant for the long haul. And finally, we've arrived at Section 5, mastering core learning outcomes, the final bosses of this module, if you will. So, synthesizing all these concepts really leaves us with 4 concrete capabilities. First off, you've got to be able to synthesize the strict requirements for your edge-based Docker and Kubernetes deployments. Once you've got that, you move on to actually designing the lightweight containers tailored specifically for those tightly constrained systems. Next, you have to take those vital distributed techniques we talked about, time ordering, clock synchronization, distributed snapshots, and apply them into real functioning IoT applications. And ultimately, it all ties together. It's about seamlessly applying all these lightweight containerization concepts to architect a cohesive, highly functional edge cloud system. Which brings us to one final, big question to leave you with today. How are you going to apply these lightweight containerization concepts in your very next project?
Because think about it. Once you master the constraints of the edge, the precise synchronization, the lightweight storage, the container middleware, those traditional limits of cloud computing, they completely disappear. The tools are right here, ready to go. So what are you going to build with them out at the edge?